continue learning about laws of exponents. So in this warm-up, we're going to compare negative exponents to positive exponents and try to see what's happening. So you can use your calculator to help you here. Well, the x represents what we're going to replace the exponent with. So in our calculator, we can type in 3 raised to the power of -3. And what is that going to be?
1 over -27.
So it's going to be 1 over 27. So I want you to do that for the rest of these. Fill in this table, and we'll go over it real soon. All right, what's 3 to the power of -2? 1/9. 3 to the power of -1. 1/3. Then 3 to the power of 0. 1, and then what? 3, 9, 27. All right, we're going to talk about what's happening in this table real soon. Well, let's first complete the following table. So now our base value is a fraction. So 1/4 to the power of -3, what's that going to be? 64. All right, so let's complete this table, and then we're going to make a comparison of what's happening with these positive and negative exponents. What's 1/4 to the power of -2? 16. 1/4 to the power of -1. 4, and then what? 1. 1/4 to the power of 1. 1/4. And 1/4 squared. 1/16. And then 1 over 64. Okay, we're going to talk about what's happening here, and I'm going to try to explain what's going on in just a minute, but I'm going to let y'all talk amongst yourselves first. All right, so one thing that was noticed about the values raised to the power of 0, in both situations, raising to the power of 0 gave us a value of 1. Really, any number raised to the power of 0 will give you 1, with one exception. There's one number that won't work for this. 0. X cannot be 0. But any value raised to the power of 0 will give us 1. And I'll talk about why that is real soon. But then we notice, what does an exponent really mean that's happening? What are we doing?
The number of times the number is being multiplied.
Yeah. How many times it's being multiplied by itself? It's multiplying over and over. So here, that 3 is our base, and that 3 is being multiplied over and over. Times 3, times 3, times 3. All right, but if it's a negative exponent is like saying the opposite. Negative is the same thing as the opposite. So what's the opposite of multiplying over and over? So the opposite of multiplying, we're going to be dividing. So going backwards with a negative exponent, it's really like saying we're dividing by 3. Dividing by 3. Dividing by 3. Yeah. So it's like the opposite of it. Now notice, some people were surprised that there were no negative answers here. But remember exponential functions. What type of exponential function is this? Growth or decay? Growth. Is it ever going to have a negative y value? No, it's never going to have a negative y value because y equals 0 is that asymptote. It'll approach that and it'll never get to pass. It will never go below the origin, below the x-axis. So it's just being divided by 3 when we're going backwards. All right, what about this next one? What type of exponential function is this? Decay. So that's why it's going down from left to right. But here, we know that 1/4 to the power, anything to the power of 1 is itself. 1/4 squared is 1/4 times itself, which is 1/16. That makes sense. So then over here, 1/4 to the power of -2 is like saying we're doing the opposite of multiplying by 1/4 or dividing by 1/4. So really this is like times 1/4 when we're going forward, multiplying by 1/4. But when we're going backwards, when it's a negative exponent, we're going to do the opposite of multiplying, which is division. And when we take a number like, I'll start with 4. If I take a number like 4 and I divide by 1/4, dividing by a fraction is the same thing as multiplying by the reciprocal, but it's getting larger when we're going backwards. Something that a student pointed out was this example right here. 3 to the power of -3 is the same thing as 1 over 3 to the power of a positive 3. It's a match. 3 raised to the power of 3 was 27. 3 raised to the power of -3 was 1 over 27. And a fraction flip like that, remember what that's called? Reciprocal. So it's the reciprocal. So for negative exponents, what's happening compared to its equivalent number, like 3 to the power of 3 is 27, whereas 3 to the power of -3 is 1 over 27. It's the reciprocal. It's a reciprocal, but there's no negatives in our answer because if we were to graph it, it's never going to approach a negative y value. So try. All right. Yes. Okay, so right here, we're going to apply some of the rules we learned yesterday and then some of the rules we're learning today. So this is an example of a quotient of powers. And when it's a quotient of powers, what do we do with our exponents? Subtract them. So we would do 5 minus 5, which is what? 0. So this is the same thing as x to the power of 0. And anything to the power of 0 is what? 1. But it makes sense because a number divided by itself is 1. So it works out. All right, here we have a product of powers. What do we do with our exponents when there's a product of powers? We add them. So 3 plus a -3. So 3 plus a -3 would be what? Would be 0. So it's like saying b to the power of 0, which would be what? 1. And then a reminder for this one, this is called the power of powers. And the power of powers, what do we do with the exponents? Multiply. 7 times 0 is what? 0. So 10 to the power of 0. So these are all, this first row is examples of 1. So the main concept is anything raised to the power of 0. With the exception of 0. 1. Something that I think will be beneficial for y'all to know is the parts of the power. So let's say we have 5x squared. There's a name for the number in front of that. Coefficients. All right, that 5 is called the coefficient. It's not being raised to the power of 2. It's just going to multiply to x to the power of 2. All right, and this x, this variable of x has a special name. Anything raised to a power or raised to an exponent is the base. And then this little 2 right here, that's our exponent. So coefficient multiplies the power. The base is the number that's repeatedly multiplied over and over. And the exponent tells you how many times you're multiplying it. So what we just talked about before that, the different parts, is the 0 property. Now this one's not on the star chart, but when in doubt, you can put anything in the calculator, raise to the power of 0, and you'll see it's going to be 1. So it's not on the star chart. It could be on the star itself. All right, so it's not on the star chart, but if it was, it would say something like anything to the power of 0 is 1. Actually, it would probably use a to the power of 0 is 1, since that's all the variables they chose on the star chart. All right, so a couple of examples. Oh, and this x cannot be 0, just so you know. That base cannot be 0, but anything else, it will be 1. So a couple of examples we have is 5x to the power of 0. What would that be? 5, because the x to the power of 0 is 1, and it's 5 times 2. And then another example we have is a times b cubed all to the power of 0. So that's going to become anything, a is going to now become to the power of 0, b is going to become to the power of 0. So that whole thing equals a 1. That whole thing is being raised to the power of 0, which will be 1. Right. And then the last example I want to show you is, let's do a to the power of 0, b squared. What would that be?
B squared.
It's b squared. So we'd be left with a b squared, but the a to the power of 0 would just be a 1. All right, on this problem right here, we have x to the power of -3. What's the coefficient of this if it's not written? 1. If it's not written, there's a coefficient of 1. But remember, with a negative exponent, instead of multiplying by x over and over, it's like saying divided by x over and over. So it's like saying we're taking that 1 coefficient and we're dividing by x, dividing by x, dividing by x. So dividing by x, dividing by anything, is the same thing as multiplying by its reciprocal. Times 1 over x, times 1 over x, times 1 over x. So I can rewrite x to the power of -3 as 1 over x to the power of a positive 3. Where it's the reciprocal, it's going to go to the bottom of the fraction, but now it's going to change its exponent to a positive. Let's do a couple more. So here we have our 2, and the 2 is left alone instead of exponent of 1. It's invisible. But that r is being raised to -4, meaning instead of multiplying r over and over, we're going to do the opposite and divide r over and over. Exactly. So what this ends up being is going to be 2 over r to the power of 4. Or I could do 2 times 1 over r times 1 over r times 1 over r times 1 over r, just like I did right here. Okay, so what you notice with these first 2 examples is that what happened was the negative, that x to the -3, it got moved to the denominator. It's a reciprocal and it changed sign. So if there's a power that's in the denominator and it's negative, if it's in the denominator and it's negative, we would do the reciprocal of that, which would be a to the power of 6 over 1, or just a to the power of 6. So for negatives, do the reciprocal is the shortcut. The reciprocal, and then make it a positive sign. Now, something that's important. When we're simplifying powers, if there's a negative in your answer, you're not finished. We need to rewrite it so that there's no negative exponents. Exponents cannot be negative, or it's not fully simplified. So we just move its position in a fraction. So I'm going to get a few more examples here. Let's go back to this page right here. Oops, I'm missing it. Where did it go? Here it is. All right, negative exponents. The good news, this one is on the star chart. And on the star chart, what it says the base of a raised to the power of -n is the same thing as 1 over a to the power of positive a. All right, so you're going to inverse, meaning reciprocal. Reciprocal and make exponent positive. The reason why is because a negative exponent means division, and the opposite of division is multiplication. Well, 2, if the reciprocal of that is 1/2, they're opposite. Like reciprocals, opposite multiplication versus division. It means the same thing. Dividing by 2 is the same thing as multiplying by 1/2. So the reciprocal doesn't change anything. It just changes the sign of the power. The sign of the exponent, rather. Okay, so here are some examples. Let's say we had 5x to the power of -2. The 5 stays on the top, but where would the x to the power of -2 go? Where would it go? Yeah, it goes on the bottom in the denominator. If something has a negative exponent in the numerator, we're going to move it to the denominator. If it has a negative exponent in the denominator, we move it to the numerator. Let's do a couple more examples. Let's say I have a squared over b to the power of -1. Which of those is going to move places? The negative 1, b to the power of negative 1. So if it's on the bottom in the denominator, where's it going to move to? To the top, the numerator. So this is going to be a squared is left alone in that spot because it's already positive exponent. And b is going to join. Now, b positive 1, we don't need to write that positive. Also, we're just left with 1 on the bottom. We don't need to write that either. So it's just a squared. Right? And then a third example here. Let's do c to the power of negative 3 over a squared b to the negative 5th power. Where's my a gonna go?
It's gonna stay.
It's gonna stay because it has a positive exponent. Where's my b gonna go? On the top because it has a negative exponent, so I'm going to move it to the opposite side of my fraction and give it a positive exponent. Where's my c going to go? On the bottom because it has a negative exponent, so we move it to the bottom and give it a positive exponent. Okay. So that's how negative exponents work. They just move their position.
Okay.
Wonderful. Okay, so this first example here, we're going to mix them up together. So a, b, c is all being raised to the power of 0. Anything raised to the power of 0 is 1. Or you could think it's not going to be a0, which is 1, b0, which is 1, c0, which is 1. It's just going to be 1. Right? This next problem here, what's going to move spots?
The y.
The y and the z. So the 3x is going to stay on top. Where's the y going to go?
Go down.
Down at the bottom, and we're going to make that exponent positive. Where's the z going to go? On the top, and that exponent's going to be positive. Again, it's not fully simplified unless there's no negative exponents. Right? And then what about this last one? 2. X to the power of 1 is just 1, so it's just 2. Okay, so a few of these examples, a to the power of 4 raised to the power of negative 3. For powers of powers, what should we do with those exponents? Multiply. So we're going to multiply 4 times the negative 3, which is negative 12. So it's a to the power of negative 12. Can we leave it like that? No, so how do I rewrite it for a positive exponent?
1 over a to the 12th.
Yep, that's our answer. 1 over a to the power of 12. Okay. All right, this next one, let's talk about simplifying. Let's start with the coefficient values 5 and 20. How can I simplify 5 over 20? 1. Yep. All right, now I'm going to move on to my x's. X to the power of 3 and x to the power of 2. They're in a fraction, meaning it's a quotient. So what do I do with my exponents for quotients? Subtract it. So I subtract the numerator minus the denominator. 3 minus 2. So 3 minus 2? Yeah, I'll get 1.
2 is definitely not negative 1.
It's a, so we have 1 on the top, 4 on the bottom. Now it's a positive 1 for x right there. All right, and then what about my y is? Y is plus 9. So it's going to be 9 minus a negative 2, which is the same as plus 2, which will be 11. Now, if that confused you, I'm going to show you another way we can do this. Y9 over y negative 2 is the same thing as saying y9 and y positive 2 on top. In that case, we combine the 9 and the 2 together to make that 11. All right, so our final answer is x, y to the power of 11 over 4. Those ones aren't needed, they're just extra. All right, there's a lot of problems that y'all need to practice, and we're going to give you plenty of practice over the next few days. Check the keys on Canvas, ask questions, and prepare for your test. Don't forget to like and subscribe to my channel.